Hi everyone, and welcome to this talk on a design pattern for geovisualization content description. The talk will be about a content ontology design pattern, and by geovisualization we mean an artifact whose visual property encodes geographic data. So let me start with the motivation for the work. About 10, 11 years ago, there was a study about the Sense.us platform. And one of the novelty, I would say, of that platform was what you can see here down on the diagram. It was the possibility given to user to add a comment about things that they see interesting on the visualization. Typically, the user will start by adding a comment, and in that process, he will get the possibility of adding graphical annotation. So the idea of a graphical annotation was to simulate the pointing that we have during face-to-face communication. So typically, he would then add this graphical annotation and then move on. So the authors studied or kind of collected data about the user's satisfaction overall, and the user, the participant, were really satisfied with the possibility to comment, with the feature of graphical annotation, and among the comments that they gave, the majority of them, 80%, was or were observation. Typically, observation were notes highlighting an outlier or a trend. So what we learn about this is that user, when given the opportunity, can contribute useful observation about visualization. Now, there's another study which has reported something that goes in line with this finding. What they did was to study users doing data analysis sessions, and what they reported was that note-taking is a key activity throughout this session. The implication of this finding is that we need software to support individual as well as group-based annotation of visual artifacts during their analysis with them. Now, strictly speaking, the finding of this study applies only to co-located collaboration, because as you can see here on the figures, the participants were co-located. So it's rather finding that applies to synchronous collaboration, but my assumption is that this finding holds also for the case of asynchronous collaboration, which is more typical for the web. So two findings from previous study that I built upon, and then an observation, namely the fact that there are an increasing number of visualization available on the web. Here is just examples of platforms that try to collect and these visualization and act as a single platform, bringing them together. The tree graph gallery, data USA, data smart city solution, ArcGIS story map, and visualizing cities. So given that we have an increasing number of visualization, we probably will need in the future, in the not so distant future, more than one person to extract all hidden insight of these resources. The key question is then, how do we model insight gleaned during, after the interaction with visualization? And the key benefit that we have here in mind is to make rich content of geovisualization machine processable for the purpose of advanced semantic search. Now, there are two works I'll briefly mention that are quite close to what we are doing here. The first one is the map legend ontology. It's work that has been presented 4 years ago at WOP, where the author proposed an ontology for map legend. And what they suggest is that you have a map which has a legend, and that legend consists of an item, and that item in turn consists of different symbols, among which you have categorized symbol, graduated size symbol, or graduated growth symbol. All the ontology helped to answer questions related to the topic of a map. For example, which mountains or which map show mountain, or which maps show highway or a park. Another ontology worth mentioning is the historic maps Fen ontology, which was suggested by Scheider and colleagues. The starting point here was historical maps, and the authors were interested in making historical map or the content of historical map more searchable. They have a much bigger ontology than what I show here. In particular, there is an event part of the ontology which shows things like wars. But this object part show things like rivers, sea, lake, and helps to answer questions like which historical map show lake, or which historical map show wood and fields. So these two works have helped already address partly the question or the problem of querying map content, but they do not quite precisely do what we intend to do, namely model which interesting facts a given geovisualization portray. And we will go quickly through the GeoInsight pattern that I have proposed. I have reused two existing patterns, the time index situation pattern, because I see insight capture, or we can model insight capture as a time index situation. And I reuse also the information realization pattern, because we could model the content statement as an information realization. So a content statement can appear in three different forms: as a graphical note, which is typically a URI, a textual description, literal, or a machine readable description. And in the context of the work, I've modeled that machine readable description as a named graph. Now below, what we can see is going from left to right, we have the when, which is a time interval, which can also be turned into a timestamp when beginning and the end of the time interval are the same. Then we have the what, and the key, or one of the key notions here, is the notion of data view, because the visualization is always a perspective on the data. And we can have the data table as a data view, which is data table is basically a matrix. We have a map, which is a spatially ordered network, and then we have a chart when you have neither a data table nor a map. Then we have the possibility to do thematic grouping. That's the role of the thematic layer. We have agents that create or endorse a content statement, and that content statement is valid for a spatial or temporal region. There are things that are not shown here, but that can easily be added to. For example, modeling the provenance of the content statement using prof that was influenced by here, or modeling the reason for recording a content statement. That could also be added using concept from the design intent ontology. If you recall the first slide, we had the idea that observation were the most, the type of comment most recurrent in contribution from users, and then there's the question of which type of observation exactly, and this is what this part of the pattern tries to address. We have trend and outlier, which were observed already in earlier work, but we do have things like cluster, distribution, frequency, correlation, which were already identified in the information visualization literature. Now, anything that is neither of the six is an observation. Now, to evaluate, I focused on aspects of design, namely consistency and expressiveness. I've used Protégé and the Hermit reasoner to evaluate consistency. DBpedia Spotlight, I use it to do the translation between textual and machine readable description. And I use the package RDF-lib to do the querying using Sparkle. The examples are available online at the link below. There are 8 different examples of geovisualization according to the literature, and all 8 have been annotated during the work, and are available also in the data available in the paper and on the link I've shown. I'll briefly go through the examples. We have aerial photographs like this picture of the deforestation of the Amazon rainforest that I have annotated in the work. Then we have tables. Here you can see it, but location is usually a column of tables, either using spatial coordinates or place names. We have networks, which model relationship between places. We have diagram, which are handcrafted, Minecraft map is an example. Then we have charts, which we are familiar with. Some of them have place names, like here, the SDG data. And we have symbol, which are icons that are created to model geographic data. And in this case, the author has used what he called the wheel of happiness to model world happiness, and the size of the circles is actually proportional to the values of each of the dimensions. And we have map, spatially ordered network, as I've said before, and then we have dashboard, which are basically a composition of many of the components that you have seen before, notably data table, map, or chart. So all 8 have been annotated, as I said, and then we could answer several questions. I won't go through them; they are in the paper. We had 5 competency questions, and then additional questions like which consent statement are most popular, or what trend do we see about a given country, or what patterns are highlighted by a given geovisualization. A limitation of the work is that I really focus on content statement, which is a statement that summarizes interesting facts portrayed by a visualization. Yes, that means that I didn't touch on cues. Cues were identified in existing work as anything that is not directly extracted from a visual representation. They could include reminder, hypothesis, question, evidence for or against a hypothesis that are also important but are not included in this version. Now, as ongoing work, I have a student on Python who is implementing a prototype that we will be testing coming months. As you can see here already, the 7 types of visualization are there, and we intend to compare form annotation using text, form, and annotation using speech, and to see which leads to greater user satisfaction. The annotation will be saved in schema.org. So to summarize, we will progressively need more than one person to extract all hidden insights out of visualization, and that's the gap that the GeoInsight design pattern has tried to cover. The vocabulary provided is expressive enough to cope with most common type of geovisualization on the web. Acknowledgement.